before recording, right? I should have probably mentioned it now. Okay, so systems more than one line, more than one inequality. Okay, but let's go and I just want to quickly review because I feel like I didn't drive that point home on Friday because of time. Time is always my biggest enemy. So go to page 19 real quick. We graph this. Pay very close attention to this part right here. I will be doing that, but in a lot, it's going to be a very short 3 little symbols here that's going to help me to graph. I tell myself whether it's dashed or solid, where the true region is, and where I'm going to shade. Okay, so I always tell myself that, and I will strongly encourage you to do the same. Okay, so when we graph this, the most important part is this one right here. Where is the true region? And we've determined that it was below because y is less than. That's a key for when it's isolated. It's key for determining, right, the true region is below the line. Perfect. Now, there will be for sure times where I'm going to ask you, would this point be part of the solution? 40, 30. Show your work. That means you can't just say yes or no. Okay. So let's just do a little, just try to visualize it. 40, 30 would be going way out here and then up here 30 somewhere over here, right? So if you picture my pencil, it'll be somewhere way out here. We don't know for sure if it's going to be in the true region or not. I did that on purpose. So let's go and test that for sure. I will say this, substitute into, watch this, original IQ. Not the one you rewrote. Plug it into the original, because if you made a mistake in rewriting, then you have a problem. Okay. So let's, way back is this. Way the original looked exactly like this. It doesn't matter which one you choose, but I would suggest you pick the original. And then just plug these points into them. And I'm going to warn you that I sometimes swap the x and the y on the way I give you the inequality. So make sure you put x where x is and y where the y is, okay? So 4x would be 4 times 40 minus 5 times 30 minus 10 greater than or greater than 0, not equal to. So this would be 160 minus 150 minus 10 is greater than 0. 160 minus 150 is 10, right? Minus 10 is 0, right? This would be 0. 0 is greater than 0. That's a false statement, correct? I just need you to all agree it's Monday morning, right? It's like, I don't know. If there had been an equal sign here, it would have been a true statement, but there isn't one, so this is false. False. Therefore, 40/30 is not a solution. You can say it's not a solution or it's not part of the solution. It's not found in the solution region. It all means the same thing. Okay. I will put an aside here. It fits in my notes. I'm just going to make a line here. Note, right? Aside 0 is greater than or equal to 0 is true. Okay, this is just maybe put a cloud around it like that. So it's that little difference, right? The symbol being different that makes a statement true or false. Because here you're saying 0 is greater than or equal to 0, and the or is met. So it is true. That's a true statement. Next, let's try this one. For a negative 20, so I'm not rewriting the original, I'm just going off of this one here. Minus 5 times 50 minus 10 is greater than 0. Let's figure this one out. 4 times negative 20 is negative 80. 5 times 5 is 25, so that'd be negative 250, right? Minus 10. You know this is not going to be true, right? This would give me negative 330, negative 340. False. Therefore, not a solution. It's a bit too obvious, this one, but hey. And by a quick, I don't know, like you should learn in time that in math you don't just blindly trust your answer, especially if you have a graph, right? So you should be like, okay, negative 2050, negative 2050, like you're way up here somewhere, which is definitely, most definitely in the false region, right? So it should jive. If things aren't jiving, make sure you check, okay? So this is what I mean by show your work, right? Show your work is to substitute in. Show your work is substitute in. I'm going to highlight the substitute into the original and then just do some algebra and figure out whether they're true or false. So in grade 10, Intro to Applied and Pre-Cal, they might have asked you, is this point a solution? You would have done the same thing, but you would have had an equal sign here, right? And if the left side is not equal to the right side, it was just false, right? There's no being greater than or less than. So it's the same idea, it's just symbol of inequalities here. Let's keep going. I want to make sure you know how to deal with this on page 20. Always scan, right? Scan your question. Do you notice any y variables here? Yeah. No, so this is going to be no y variable, right? This is going to be a vertical line. You should recognize that right away. Sometimes it takes combining terms for things to cancel out, and it's only then that you realize. But this is a plain as day, right? So let's collect our like terms. So 3x minus x is less than 6. So that would be 2x is less than 6. Divide by 2. Your first instinct should be always collect like terms. Always. Like that should be the first, your go-to, okay? Watch this. This is going to be a dashed line. Soon I'm just going to go D here, right? Dashed. True is where? You go to your little chart or you just memorize. That'd be even better. X is less than means that true region is on the left side. Where are you going to shade? You know what? I honestly don't care as long as you tell me where the true region is. But I will go reverse shading. I'm going to shade the opposite, so reverse. That's why I'm doing that. Because when we do systems, I am always going to do reverse shading, like no exceptions. And I'll show you why. Okay, so we go 3, we find 3 because this is x is going to 3. It's going to be a dashed line, so just go ahead and remember, if you forget that it's a dash, just erase a few sections and you turn it into a dashed line. X is less than 3. True region is here. That is the most important thing. The true region never changes regardless of what shading you use, guys. It doesn't. Okay? And then just use your ruler. That's how you, I know you, it'll look like a piece of art that I can like frame when you shade. Looks perfect, but this is my shading. Just make sure it's visible, okay? Don't be too light on it. Is 4, 7 part of the solution? So you go 4, 7. It's in the false region, right? 4, 7 is like past here. We can do false here if you want. I focus on the true region. Okay. So let's just do a quick 3x. 3x is less than x plus 6. And you're like, what about the y? Aren't you wondering what happened to the 7? This inequality doesn't have a y, so that doesn't matter. You just plug in your x value in there. So this would be 12 is less than 10, and that is false. False. Therefore, not a solution. Done. You want to make a big dot on here. 4, 7 is right there. So you can just, if this is going to throw your nice notes off, don't worry about it. But we've shown work that it's not, right? It's not. This could have very well been just a y is less than 3 question, which would have just been a horizontal line. And because it's less than, true region would have been below the line. Okay. Here you go. I'm just going to make these ones I want to have in your notes when you review them. Vertical boundary line, right? X is greater than -3. Let's just make a quick note here. This would be dashed. True is where? X is greater than. True is to the right. And I'm going to shade the opposite. So true is right, but I'm going to shade the opposite. And this is going through -3, -3. So I'm going to go 1, 2, 3 right here. It's a dashed line. Practice is going to be so important here. You make sure this whole thing is called true or solution. That means the same thing. It's the solution region is the true region. I'm going to shade the opposite because of what we're going to do next. I want you to get used to reverse shading. So basically for us, if we use reverse shading, whatever isn't shaded is going to be the good region, right? The one we're going to draw our solutions from. Horizontal boundary line is when you just have y and a number. Y and a number. Here this is going to be a solid. The true region is where? Y is less than. That means that true region is below. We're going to shade above. So you go find 4, positive 4. 1, 2, 3, 4 right there. And this is a solid line, which means that the points that land right on the line would also be considered part of the solution. So y is less than or equal to 4. I go back and I determine true is below the line, so this whole region here true or solution. So you have your special cases. These are easy to do. There's no not much to it, right? You just don't have to worry about finding 2 points. You just have that 1 point and cut through it. Okay. So make sure you practice. If you did do the homework that I assigned for this section, I'm just going to show you a couple. I would have shown you, right? You would have come across vertical. I'm trying to think here. Oh yeah, right here, 3. On page 23, question 3, that's a horizontal boundary line. We only have Y there. Right? So you came across that, just make sure you check. Apparently I didn't post the answer to 6 and 7, so I'm going to double check my answer key and make sure I update that. Let's go, can you come up on go to page 22 before I go to the systems. I would expect you to be able to come up with come up with those inequalities literally in 2 or 3 minutes, just like that. These 2 inequalities, I have 2 inequalities on the same graph. You can call this one A, and we can call this one here B, right? So come up with inequality for this one here and the inequality for B if you had to, okay? I'll update my attendance. For inequality A, it's going through 7, 0 right here. So you know it's a vertical line, so it's going to be x and 7. Okay, I'm just going to make a note here for myself. It's solid. True region is to the right. Okay, that's all you really need here. So I will make it x is greater than or equal to 7. That's it. X is greater than or equal to 7. For this inequality here, it's going through a 0, -9. Right there. So this will be y and -9 like that. I'll just make sure this is a dashed line. True region is below. Right, the solution is below here. So I'm just going to go less than, and so this is the inequality for B. This is the inequality for A. And I'm going to leave 22 for now. Sorry, the bottom 2 here, I'm going to leave those for now. I want to get to graphing systems now. Okay, so the vertical and horizontal is a lot easier. You don't need to find a slope there. So there we go. Let's go to page 29. Okay, graphing systems. So this is going to be the title of the lesson, but there's not going to be a whole lot, like 20 minutes maybe worth of that. Graphing systems. Watch this. Same as before. But you'll have multiple inequalities. So if you have systems, you have multiple inequalities on the same pane, each with their own solution panes. Work with each inequality separately to make sure you don't mix up your solution region. That's very important. Don't do them all at the same time. That's going to be your biggest enemy. Shading system, sorry. Having multiple solution region makes it difficult to determine the solution region for all inequalities. To make it easier to determine the overall solution region, we use reverse shading here more than ever. Okay. In essence, we shade out all the false regions, and the area left unshaded is the solution region. Here it is. Area left unshaded is your solution region. So I did this for you. I remember students having to copy these graphs, right, for them to understand. But this is, imagine a system and you graphed all three of them, right? There's 1, 2, 3 lines here. And technically the darkest region is your solution region. So in this case, make 3 dots like that. This is the solution region, right? I'm just going to write down SLN like that. But if you have to do this by hand, guys, it's going to be a nightmare to figure out the darkest region. It's just, I've done that. It's a nightmare, right? Students pick, like, I don't know, this one looks a little darker, right? When you do it by hand, you don't have that consistency that a computer has, right? So watch this. If you use reverse shading, whatever isn't shaded at the end of the day is your solution region. So it makes it a lot easier, right? So this is the solution region using reverse shading, okay? So that's why I will stress using reverse shading, because then you're like, hey, everything else is gone. Obviously, this is my solution here, because you shaded out the false for every inequality present. So these points inside of this little triangle, it's not always going to be a triangle, by the way. A lot of students think it has to be a triangle. No, it doesn't. And so these points in here are the solution region for all inequalities present. Okay, so let's talk about POIs real quick here. Points of intersections, POI, they're very important to me, and they will be important for you as well. The points where the boundary lines meet. Okay, points where the boundary lines meet surrounding the solution region. Okay. So watch this. This one has 3 POIs. This is the solution here. So 3 POIs. Because, right, there are lines that meet in at 3 distinct points around the solution region. Now imagine this one here. Solution right there. It's the non-shaded. And so some students are like, oh yeah, the x-intercept here, the x-intercept there. No. There's just 2 lines here. So this is the only POI here. Right? The 2 boundary lines meet only here. Only 1 POI. Right? So make sure you distinguish that and get that part right. Can I just maybe, I'll just say this, arrow, not POIs in this case. It will change when we do word problems, but if it's just a non-contextual, then those are not considered POIs. Okay, let's go to page 30. I think there's a system waiting for us. Yeah. Let's go to 30. And you're going to use all that space. Okay, so graph the following systems, then identify the solution region, include POIs. it's a good idea to graph all lines on the calculator before graphing it on paper. I will suggest that. But you do whatever works for you. But sometimes if you don't do that, some of the POIs are outside your grid, and that's frustrating. Okay? So I did this on purpose because it shows up on textbooks. Look at how it looks very complicated, doesn't it? But this is just another way of introducing inequalities. Like, hey, these are the two variables present. Then there's a bar. Then there's the inequality written. This is the one you want to focus on. Okay, so this is the inequality that you want. Same with the one below it. That's the inequality you want. So if I ever throw that at you, don't worry about it. It's just another way of presenting the information. And both of them are saying both x and y are real numbers. So that just means that any number goes, right? Decimal, fraction, you name it, right? So don't worry about that too much. But this is we're going to do one at a time. So I call this inequality 1, and this is inequality number 2, right? So the first one here, I'm going to go 4x. I'm going to bring this 6y over. This 6y, I'm going to bring it over right away. And then it's greater than 12 on the other side, like that. Okay. And so I find my intercepts right away, just like before. So 4x is equal to 12. The equal sign only shows up in here when I find the intercept because I'm focusing on the boundary line. And so this is 3. So this is 3, 0 for the x-intercept. For the y-intercept, it's negative 6y is equal to 12. Divide both by negative 6. Y is equal to negative 2, 0, negative 2. Close that. This is just so we can graph our boundary line. Let's rewrite that one in terms of y equals mx plus b. So I'm going to take this one. How about I will do this because this is your first example. Okay, so I'm going to take that. I'm going to go negative 6y is greater than the 4x comes over to the other side, subtracting. And now warning, I'm going to have to divide by a negative, right, to get rid of this. So this would be y is less than, right? This flips. And it's 4 over 6x minus 2. So it jives, right? My y-intercept is negative 2. It is also negative 2 here. This is important to me because I'm going to need that later on. But we're not done yet. Now we can tell the reason I rewrite is 2 reasons. You know where to shade. You can enter this into your calculator. That's why. So this is a dashed line. True is y is less than, so true would be below. We would be shading above. We shade the opposite region as where the true region is, especially because this is a system. So I want you to do this every time. You take your inequality, find the intercepts, rewrite, and then gather this information. We could now technically graph that one, but I'm going to go to the second inequality right away and do the same thing. So let's, I'm going to go up a little bit and use this space here for the second one. 3y is less than or equal to negative 2x plus 9. Not really the way I want it. So I'm going to bring this over to the other side. So it's going to come over 2x plus 3y less than or equal to 9. Find the intercepts. So if I go a little fast with this stuff, it's because I want to get to the graphs. So this is 2x is equal to 9. X is equal to 4.5. This is 4.50. Next, you have 3y is equal to 9. Y is equal to 303. Purely for graphing purposes, this one. Okay. And then we rewrite that one. 2x plus 3y is less than or equal to 9. I'm going to bring the 2x over to the other side. So that's negative 2x plus 9. Divide everything by 3. No worries here. Nothing needs to flip. Y is less than or equal to negative 2/3 x plus 3. And it jives, right? This y-intercept matches that y-intercept up here. Circle it. This is solid. The true region is y is less than, right? Just focus on that one. It's below. We're going to shade above. Let's enter both of these into our calculator. I want you to have an idea of what does it look like before I even graph this. I'm going to clear everything. Plot 1 is off, remember? We're not doing regressions. This unit does not have any regressions. So don't worry about that. So I'm going to do this one first. Bracket 4 divided by 6. We know that's 2/3, but those are going to be weird. Sometimes you're going to have decimals. It doesn't matter. Just leave it as is, because that's beside the point. We don't worry about reducing fractions. Negative 2 divided by 3, x. Oops, I'm going to close the bracket first. X plus 3. Make sure you look and double check. It's looking good for me. I'm going to hit graph. First one, second one. All right. Find the POI. There's only one point of intersection, right? Second trace 5. You just hit enter 3 times because that's all you have on the screen, right? And so it's 3.75, 0.5. I'm pretty sure we're going to fit that on our graph, right, guys? 3.5, like these are pretty small numbers, so we don't need to worry. But sometimes this is like negative 20, 15. So you will need to adjust your scale accordingly to make that fit. So that's why I did this. I'm going to, for now, write it down here. 3.75, 0.5. But down the road, you're going to have to decide which ones are the POIs that are applicable. Okay. So let's graph this. I'm going to do this one first. Watch on the left here, 3, 0, and then 0, negative 2. And I'm gonna see here. What did I make? I made a note that this is a dashed line. Okay. I'm going ahead and making a dashed line right across the grid. If you go outside the grid, that's no problem at all. Okay. And I'm going to label it right away. Y is less than 4/6x minus 2. I'm not shading yet though. That's the one thing that I'm not going to do just yet. Then go to the next one, 4.50. So that's 4 is here, 4.5 is right there. And 0.3 here. Remember, the slope is negative, so I do expect it to drop from left to right. Always make sure everything jives, okay? This is a solid line. There we go. I'm going to label it right away so I don't forget. And now I'm going to shade. So you have a ruler ready. Watch this. The first line here, the dashed one, I'm shading where? This is where you look. True is below, shading above. So you grab your ruler, line it up, and you lightly, everything above that line is false. All right, you're done that one. Now you go to the next one. What does it say? Shade above it. What is the other line? It's this one here. So everything above that one is shaded. So you grab your ruler, line it up. Everything above. So because we use reverse shading, so this is false. Everything is false for this dashed line, and everything above the solid is false. So basically everything around the system is false. This is your true region, and it's the solution region. I'm going to probably start calling this solution region more so because it's for all of them, the solution region. The most important point you want on here, in this case, there's only one POI right here, and that is 3.75, 0.5. Make sure you make a note there that that is your POI. Just a quick note here. You will have diagonal meets vertical. You will have diagonal meets horizontal. You'll have everything that you can possibly imagine. You just have to know, what do I already know about these lines? Graph them, shade them, right? And then just determine, okay, what's not shaded? That's the solution region. Before I go, I want to try to do this one here, but I feel like it's going to be tight. So I'm going to tell you to try 31 to 33. Homework 31 to 33. And I will post the key to that as well. But before we go, I'm just checking here. It's going to take me 2 minutes. We have 4 minutes left. 4, 5, is that a solution? 4, 5, it's not going to be. But substitute sub into both inequalities. If there's 3, you have to plug them into all 3 if I ask you to show work. So I'm going to grab that and just go 4x is greater than 6y plus 12. That's the first one. And the next one is 3y is less than negative 2x plus 9. So be very careful what you do here. 4x is 4 times 4 is greater than 6y plus 12. 16 is greater than 30 plus 12. 16 is greater than 42. Oops. Is this true? Right? False. Technically, we can stop and say it's not a solution. We can stop right there. But let's say this is true. I'm going to do the same thing. 3, 5, 3 times 5, because it's 3y, is less than or equal to negative 2x plus 9. This is 15 is less than or equal to negative 8 plus 9. 15 is less than or equal to 1. Also false. Therefore, not a solution. I think you're done anyways, but just remember, if one of them is false, done deal. It's not a solution, right? Thank you guys. Have a good rest of your